Hey John, I'm Conor Pendlebury.
And I'm Gareth Byrne.
We're here to introduce you to our CA1 design document for Bomberman Multiverse.
So let's just go straight away, and Conor will go through the game story.
So, Bomberman is a retired veteran bomb maker, and he's been teleported to an alternate multiverse called Nebula. So, Nebula is ruled by an evil Baron, and this Baron is called Vertia, and he has brought all the Bomberman alternates together in a tournament, and he's going to make them fight to the death. And they will not be able to get free until there was one victorious Bomberman, and Bomberman wants to go back to his family.
So we took our gameplay most similar to Bomberman, so our game is more of an adaptation to the original Bomberman series. So our gameplay works in a round-based system, so there will be 3 rounds with a time limit of 2 minutes per round. So we'll have up to 6 players with networking and just 2 players with a single player. So the way the gameplay works is each player starts at a position on the map, and they will have 1 bomb, and they can place that bomb and blow up breakable blocks and not break unbreakable blocks. As the game goes on, when they break the breakable blocks, they will get power-ups. These power-ups will do various things like increase their speed, increase their bomb radius, and also add negative effects. So some of the negative effects could slow you down, you lose a bomb and stuff, so you have to actually be careful what pickups you take. So the way a round ends is if the round time hits 0, the round is over, or if all players but 1 is dead. So you only have 1 life, so if a player kills you, you're gone until the next round, but your score will still be there. There are 2 ways to get scores. You can get a score from killing other players with your bombs or collecting crystals. Crystals are a rare drop from boxes. So you get 3 points for them, and you get 5 points for killing an enemy with your bomb. You will lose 1 point if you kill yourself with your own bomb. So you'll be able to hit yourself with your own bombs.
So now on to the game input.
So for the gameplay input, we basically want to have both player keyboard controls and the gamepad controls. So for our single player, we've set up here like basically a table of the controls, so it's clear what to do. So we have W, S, A, and D to move around as player 1. This will also be used for moving around in the menus, and the up arrow keys will be for player 2, so they can also move around. Since we only have 1 major button in the game to place a bomb, there's not much other gameplay, so we only need 1 key binding to that. So we have E for player 1 and space. So for the multiplayer version, since there's only going to be 1 player playing it on 1 computer at a time, to enter chat they will press tab. So they can enter the chat and put in up to 256 characters in the chat. So we're going to limit the amount of characters they place in chat. And we just want to, if you want to quit the game, just press escape. Gamepad controls are pretty much similar, except for you use the left analog stick to move around. And to place the bomb, you use the A button. If you're using PlayStation controller, you use the X button instead. And to enter chat, you use start, and to quit the game, you use select. So for menu, in the menu you can use the mouse to click on our buttons, and to move around with a controller you can use the D-pad. So instead of the analogs, which are more sensitive, the D-pad is less sensitive, so it'll be easier to go through them, and I'll go through how the UI works later. So for the graphics, we mainly use the sprites that we found online from the original Bomberman games. So all the images will be in the PNG format, and we took some of our images and basically edited them in Photoshop. So for each character we're going to need another, basically different color sprite palette. So if you see here, we changed the colors slightly. So each Bomberman has a different bobble on top of their hat, a different t-shirt, and different shoes. Basically this will indicate when the player is playing the game that they know which character they are, because if they're all the same character, just alternate versions of it, and it worked well with our narrative. The same can be said similar to our animations. So in our animations, we basically will have one animation sheet, and we will swap the colors. So as you can see here, we have the forward walk, backwards walk, and walk right and walk left. So we do. So each one of these will be the same, but for each different character, we'll change the colors. So for menus, we have in our game we have 3 menus. For the single player version, we're only going to have 2, which is going to be the main menu and the controls. In the multiplayer, we're going to have a waiting room. So before you enter the game, there's be a state where you wait, and then you go wait for the amount of players, and the host starts the game. So for the in-game UI, we want a timer. We need a timer in the center screen, so that'll tick down from backwards from 2 minutes, and we'll show the time that's left in the round. It will also have a score, so basically that'll indicate how much score the player has, and this will continue for each round until after 3 rounds, where we declare a winner who has the overall score. So if we look at our menu here, our main menu, we have just a start, control, and quit button. This bomb symbol here will basically be an indicator to where you are in the options, so we'll move down as you the highlighted option. In our controls menu, we have it clearly explained what PC controls and Xbox controls, which Xbox is most likely what we're going to be using, to control, just to give an indication where how the player controls. Also, we just have a back button, so you go back to the main menu. So in the waiting room, we basically have, whenever our player joins, we'll basically say a player has joined, and if there's space, it'll be waiting. And the start button will only appear for their host. So whenever the host starts the game, they'll stop searching, and then the host quits, they'll end the connection. And this is just similar for our UI. So we're also going to have our chat box at the bottom of the screen. So basically, each of these players, if we only have 2 players, there will be only 2 players appearing at the top. We will only draw these 6 players if there's 6 players in the game at once. This will save from some draw calls. And for chat, we put it on the bottom right because it seems to be less intrusive there if you put it to the side of the screen, because the game level will grow as the amount of players, so we want to keep it as tightly confined in the center of the screen as possible.
So let's go on to collision detection and physics. So for collision detection, our game will be axis aligned bending box collision for all our entities. As it's the tile map, we won't need rotating bending box collision because it'll literally just be moving up, down, left and right. In the game, players can collide with unbreakable blocks, destructible blocks, bombs, bomb radius and power-ups. A bomb radius being damage thrown from another player's bomb. As the game uses a tile-based system, one player occupies 1 tile, and so on with a destructible block or a pickup. Also, a pickup will be removed from a tile, and then a player will move up to that tile upon collision with that block. When a player collides with a power-up, they'll pick it up and they'll add it to the player's stats. The player cannot pass through blocks, as they will be collidable and they'll be moved back to the position before. So it'll be what's the word for? It'll be intersection. Yeah. So the x and y values will move them back to the position before they actually collided with the object. So every object will have a type. The types in the game are pickup, bomb, player, and so on. This approach is needed to distinguish if in this statement what the game to do when you say, so if collide with pickup, we can say delete or remove pickup. So here's just a list of what the player will collide with. like the bounds, the wall player, so on. So below is an example of collision detection. The blue player is trying to move up into the red player's block. This isn't going to work, so he's going to be set back to the position he was before the collision occurred. So for the physics in the game, we're literally going to be controlling the player's movement, which is the velocity X and the velocity Y, which is going to control the speed of the player when he's moving. Acceleration will also be used to gather momentum. It's a fast-paced game, so we want to be able to gather an awful lot of momentum around the map, which may or may not be difficult because of the collisions in the way, but that's what makes it fun. So for tile mapping, the game is tile map. It uses a tile map system, so each player, block and pickup will be set on one tile. The map will be top-down view, so it's easy to distinguish everything on the map, and as it's going to be a hectic scene with 6 players, we want to be able to see everything. We will implement the tile maps by using texture blocks, which will be implemented using text files for all the levels. So with this we can have loading multiple text files, and there's no limit to the text files we can use. We can literally load in levels as we please. We'd have different numbers, say IDs, say 0 or 1 or 2. This will literally call the ID and place it in the level. So if I have 0, which is a grass space, or 1, which is an unbreakable block, I can literally write in the text file and populate the map using those IDs. So we'll have different size maps. This will be because we'll have different players. We'll have players 2 to 6. So if we have 2 players in the game, it's going to be a small default map. If we have more than 2, we're more than likely going to move up to a 19 by 17 dimension map, and this one will have no border, whereas the default map 15 by 13 dimensions will. It's important to use tile maps to be able to reuse the tiles to make very large maps, and populate them as we wish. So here's an example of one of the text files. This literally might be level 1 .map or .text, and then as you can see, 0s would be the grasses, and 1 would be a border, and 2s would be a different object.
So if we just show what that would look up, so you have the 1s, which would be the unbreakable blocks, and the 0s, which are the green blocks, and then we have the breakable blocks, which are just these here.
Now, so I'm going to move on to sound. So in our game we have music and sound effects. We have a musical score, which is pacey to go along with the actual gameplay, which is very fast paced. We also have a lot of sound effects for different things, like a player moving, which there's a walk sound. There'll also be a sound emitting to give audio feedback along with visual feedback. Like I said, the musical score is upbeat and pacey to coincide with the crazy gameplay. The game will feature also menu sounds and a musical score, which is a lot more calmer than the actual gameplay, but it's just to try and get you into. The software we'll be using is Zact with DirectX. Zact allows developers to store sound files in a WAV bank, a sound bank, and then we can literally just call them in with cues and play them out very easily, and we can loop and things like that, which the musical score will do. It literally just repeat. We'll keep it on a loop. So when editing the sounds, also we'll be using Audacity and to change anything we need. Like, as it's a fast-paced game, we may need to make it more pacier. So here's some examples of the sounds. We have bomb explosions. We have a variation of bomb explosions to keep the sounds a little bit more dynamic. We also have sounds for the crystals, or our pickups, and sound occurring when the player dies, and then the player walk. For the musical score, we have 2 musical scores, and we have a menu score. 2 musical scores for variation. We may decide to swap them in game during a level, or keep them based by levels.
Okay, so we're running out of time in this screencast, so we're going to talk about the UML diagrams and networking in the next one.